Good afternoon. My name is Charlie Baum, and we're going to be continuing our discussion of oligopolies by looking at sequential move games. In our first lecture on oligopolies, we used payoff matrices to examine simultaneous move games. A simultaneous move game is where both firms must make their decisions without knowing what the other firm is going to do. A sequential move game is where one firm moves first, their decision is made, and their decision is revealed to all other players and firms, and then the other firm moves second. With a sequential move game, we could use a payoff matrix or a decision tree. Since we used payoff matrices in our first discussion on simultaneous move games, I want to use decision trees in this lecture so that you can get some practice using that format. But I do want to make it clear that you could use a payoff matrix to examine a sequential move game. In a sequential move game, one firm moves first, then their decision is revealed to the other firm, and then that second firm moves last. In the first example that we're going to consider, Apple is going to decide whether to charge a high or low price for its laptop, and then Dell is going to decide whether to enter the industry or not. Dell is going to learn whether Apple has charged a high or low price before it must make its entry decision. Here is how Apple will decide what to do. Apple will recognize that if it charges $1,000, which is the high price, that Dell will then maximize its profits by choosing a 16% rate of return over no return, and this means Dell will enter. From Apple's point of view, this would correspond to profits of a 16% rate of return. Apple has another option though. Apple could charge the lower price. If Apple charges the lower price, then Dell learns they're at the second node. Dell will then maximize profits. Since 5% is a better rate of return than no rate of return, Dell will pick to enter the industry, and this means from Apple's point of view, their rate of return will be 5%. Since a 5% rate of return is less than a 16% rate of return, this means what Apple will do is they will pick the first branch, which is the high price. That prevents anything in the second branch from occurring, and then Dell will learn that they're at the first node. Dell will move second, and this will be to enter. And if Dell enters the industry, then Apple's rate of return will be 16%, and Dell's rate of return will be 6%. In this example, you may wonder why Apple isn't able to achieve a rate of return of 20%. This is because if it charges a price of $800, Dell will enter, and this means that Apple's rate of return will be 5%. Apple won't get to this lower box. So here we see the outcome if Apple picks $1,000. Here we see the outcome if Dell didn't enter, but that's not Dell's best outcome. Apple cannot deter Dell from entering, and this means that the outcome for the sequential move game will be the first green box. Okay, in a second game, let's suppose that Dell must offer Trulmaj either $20 or $30 for Trulmaj's software, and then Trulmaj moves second by either accepting or not accepting the offer. If Dell offers $30, then Trulmaj will accept because 5 million is better than 2 million, and Dell's profits will be 10 million. Dell, however, could offer $20. Dell gets to move first. If they offer $20, then Trulmaj would learn that they're at the second node. Trulmaj would maximize profits by picking to accept the offer, and this means Dell's profits would be 15 million. Since 15 million is greater than 10 million, this means that what Dell will in fact do is they will offer a price of $20. TrueModge will accept. This eliminates the top half of the decision tree from occurring, and Dell's profits will be 15 million and TrueModge's will be 3 million. Of course, TrueModge would rather Dell offer them $30. The reason why they would rather Dell offer them $30 is because $30 with an acceptance would generate profits of $5 million for TrueModge. So what if TrueModge threatens to reject the offer if Dell offers the low price? This is a threat designed to get the firm that moves first to take a particular action. But Dell will recognize that this threat is non-credible. It's a non-credible threat because if Dell picks the price of $20 to offer TrueModge, then TrueModge is better off accepting and earning $3 million than rejecting and earning $2 million, and so Dell will in fact move first by picking $20. TrueModge will accept. Their threat is not credible. Once Dell has offered $20, TrueModge is better off accepting and receiving $3 million in profits than rejecting and receiving $2 million in profits. This is an example of a threat made by the second firm designed to influence the way the game is played, but if the threat is not a credible threat, then it should not affect the first firm's decision.